Hello everyone and welcome to this bite-sized course on networking. Now, in this course, we will be focusing on basics of networking and we will try to explain things such as why is networking important and how does a simple network work. Also, we will talk about what different types of networks are there and all the general things about networking. So by the end of this mini course, you should know exactly how a simple network functions. Okay, but let us start from the very basics, and that would be to define what even is networking. Well, networking, simply put, is the practice of connecting multiple devices or computers to share information and resources. It is like building a digital highway that allows data to flow seamlessly from one point to another. Now, before computers were connected, you could only perform tasks on one machine, and if you needed to transfer something to a different machine, you would need to physically take the data on a disk or a drive and walk to the other machine to import that data. Networking solved that, as now we can transfer and share data to the other side of the world in a matter of seconds. Now that we know the definition of networking, let's explore why is it so important. Well, there are many reasons why networking is important and why it changed the world as much as it did. First reason we already mentioned, and that is global connectivity. Networking connects people and businesses around the world, fostering global communication and collaboration. It allows us to send emails, make video calls, and share information with anyone, anywhere. It also provides efficiency and productivity, since in the business world, networking enhances efficiency by enabling employees to access shared resources and data. This also boosts productivity and streamlines operations. Now, another benefit of networking is information sharing. Information sharing was revolutionized with introduction of networking. Social networking platforms and websites have changed the way we share information, ideas, and experiences with global audience. Networking also had an economic impact, since networking has become an integral part of the global economy. We have e-commerce, online banking, and digital transactions which all rely on secure networks. And let us not forget the innovation. Networking fuels technological innovation. It's the foundation of the Internet of Things, smart homes, and, for example, autonomous vehicles. So we can say that, in conclusion, networking is the backbone of our digital age. It connects us, empowers us, and fuels innovation. So whether you're sending an email, browsing social media, or streaming a movie, remember that networking is the invisible force that keeps our interconnected world running smoothly. Alright, now that we know the definition of networking and why networking is important in today's world, it is time to shift our focus to the technical sides of networking. So we will start off by discussing what different types of networks are there. Okay, let us start with something simple. We mentioned in the last lecture what exactly networking is and why it is important, as well as what impact it had in the last decades, but now let us get more technical and discuss what different types of networks are there. So there are several types that I want you to remember and that you will hear a lot about. Here are the four main ones. We have PAN, LAN, MAN, and WAN. Now, PAN is short for Personal Area Network. LAN is short for Local Area Network, MAN is short for Metropolitan Area Network, and WAN is short for Wide Area Network. So let's start by discussing what PAN is. So PAN, or Personal Area Network, is the most basic type of computer network. A personal area network connects electronic devices within a user's immediate area. The size of a PAN ranges from a few centimeters to a few meters. Now, one of the most common real-world examples of PAN is the connection between a Bluetooth earpiece and a smartphone. PANs can also connect laptops, tablets, printers, keyboards, and other computerized devices. Now, PAN network connections can either be wired or wireless. Wired connections methods include USB and FireWire, while wireless connection methods include Bluetooth, which is the most common, but also Wi-Fi, IRDA, and Zigbee. The next one that we want to know about, which is the one that you will mostly encounter and hear about, and that is LAN or local area network. A local area network is a collection of devices connected together in one physical location, such as a building, an office, or home. A LAN can be small or large, ranging from a home network with one user to an enterprise network with thousands of users and devices in an office or school. Usually the distance that it covers can be anything from several meters up to 2 kilometers. Now, regardless of size, a LAN's single defining characteristic is that it connects devices that are in a single limited area. In general, there are two types of LANs, which are client-server LANs and peer-to-peer LANs. Examples of LAN are networking in a home, school, library, laboratory, college, office, and so on. Now, besides LAN, we also have something that you won't hear that often about, and that is Metropolitan Area Network. Now, a MAN is larger than local area network, but smaller than a wide area network. This is the type of computer network that connects computers over a geographical distance through a shared communication path over a city, a town, or metropolitan area. This network mainly uses FDDI or CDDI and ATM as the technology, with a range from 5 kilometers to 50 kilometers. Its transmission speed is average and it is difficult to maintain, and it also comes with a pretty high cost. And lastly, we have WAN or wide area network. Now, a wide area network is a larger network of information that is not tied to a single location. WANs can facilitate communication, the sharing of information, and much more between devices from around the world through something called a WAN provider. WANs can be vital for international businesses, but they are also essential for everyday use, as the internet is considered the largest WAN in the world. If wide area connections didn't exist, organizations would be isolated to restricted areas or specific geographic regions. Local area networks would allow organizations to work within their building, but growth to outside areas, either different cities or different countries, would not be possible. It is important to mention that WANs are very difficult to maintain. Okay. Now, these would be some common types of networks that you will hear about, as well as their basic characteristics. Besides these, you will also hear about VLANs or wireless local area network, storage area network or SAN, and virtual private network or VPN, but the ones that we mentioned in this video are the ones that you should definitely remember. Okay. Now that we mentioned most common types of networks, let us discuss further and in more details about local area network and wide area network in the next lecture. Alright, I want to talk a little bit more about the most common two types of networks, which are local area network and wide area network. So do you remember from the last video what LAN and WAN are? LAN, we said, is local area network. This is typically found in your homes, offices, schools, libraries, or generally in smaller places. It is designed for connecting devices like computers, printers, and servers in a close proximity environment. So let's, for example, take home network in this case. Your home network is a local area network or LAN. It consists of several devices, including your laptops, computers, printers, mobile phones, and a router. Now, router is a device which we'll talk about in more details in the next lecture. But for this case, just remember that router is an important device inside a network. All these devices are in close proximity of one another, which is why it is called local area network. Now keep in mind there is also something called VLAN, which we mentioned in the last lecture, and that stands for Wireless Local Area Network, and it is the same thing just for wireless devices. These devices inside of local area network are then given something called private or local IP addresses. IP addresses are also something that we will talk about later, but for now remember that these local IP addresses are something that these devices use to communicate inside the local area network. Another thing about LANs is that they are typically owned, operated and controlled by a single organization or entity. This allows for a high level of customization and security. LANs also typically offer higher data transfer speeds and bandwidth compared to wide area network. This is because LANs are designed for local and internal use, allowing for faster communication between devices. Also, local area networks are generally more cost-effective to set up and maintain since they cover smaller areas and involve fewer networking resources. Now, WANs, on the other hand, is a wide area network. In its simplest form, a wide area network is a collection of local area networks or other networks that communicate with one another. A wide area network is essentially a network of networks, with the internet being the world's largest WAN. Examples of WANs include the internet, a global corporate network connecting offices worldwide, or a telecommunication network spanning a country. Wide area networks can also be used in a military. Now, some of the advantages of wide area networks are that you can share information and files over a larger area. WAN helps you to cover a larger geographical area, so for example, business offices situated at a longer distances can easily communicate, thanks to wide area network. But some of the disadvantages of WAN is that the initial setup cost of it is quite high. It is difficult to maintain the WAN network as you need skilled technicians and network administrators. It also requires more time to resolve issues because of the involvement of multiple wired and wireless technologies. So these would be some of the basic stuff to remember. So let's recap real quick. In summary, LANs and WANs serve different purposes based on their geographic coverage and scale. LANs are localized networks used for internal communication within a limited area, while wide area networks connect LANs across larger geographic regions, enabling global communication. Each has its own advantages, and they're often used in conjunction to create a comprehensive network infrastructure. Okay, let us make a quick pause. I just want to recap what are the goals for this course. The goals would be to actually understand how a small network works. And if you can see in front of you, we have an image where everything is exchanged with question marks. This image is actually a small network, and these question marks exchange various different information such as devices, protocols, and other ways of communication inside the network. All of this is something that we are yet to cover, so as the lectures go by and as we gain more knowledge, we will be updating this image, and hopefully by the end of the course, you will fully understand how a simple network functions. Alright. Let's not make this any longer, and let's move on to the next lecture where we are going to shift our focus on MAC addresses. Okay, we talked about LAN and other types of networks in previous two videos. But before we dive into different network devices and their purpose, we must first mention how are these devices identified on these networks. There are two main things that identify a device inside a network. We have MAC addresses and IP addresses. Now, the main difference between these two is that MAC addresses are unique, while IP addresses are not always unique for every device. Now, since we will talk about IP addresses later in the course, let us now shift our focus just on talking about MAC addresses. So, what are MAC addresses? A MAC, or Media Access Control Address, also known as hardware address or physical address, is a unique identifier assigned to a network interface controller or network adapter in a computer or networking device. Now, MAC addresses are used at the data link layer or layer 2 of the OSI model to identify devices within a local network such as an Ethernet or Wi-Fi network. Some of the key characteristics of MAC address is, as we mentioned, uniqueness. Each MAC address in the world should be globally unique. This uniqueness is ensured by Institute of Electrical and Electronics Engineers, which allocates specific blocks of MAC addresses to different manufacturers. Another characteristic of MAC address is that it is non-changing. While it is possible to change or spoof a MAC address, it is typically a permanent, factory-assigned identifier. MAC addresses are designed to remain constant for the life of the network interface. They are also fixed format, and this means that MAC addresses are typically represented as a series of 6 pairs of hexadecimal digits separated by colons or hyphens. The first 3 pairs often indicate the manufacturer's identifier, while the last 3 pairs are the device's unique identifier. Now, to understand this, here's an example of how a MAC address looks like. The first 6 digits of the MAC address, as we mentioned, identify the manufacturer, while the rightmost 6 digits represent the unique identifier assigned by the manufacturer to the specific network interface card or device. This identifier is unique among the devices produced by that manufacturer and is often referred to as the device ID. Alright, these would be the basic things that you should know about MAC addresses. Later in the course, we will see commands that allow us to find out our MAC address on our device, but for now, let us move on to the next lecture where we will talk about important network device or network components. Okay, enough about types of networks. Let's finally dive deeper and figure out what this network even consisted of and how does it actually work. How is data being transferred between the networks, and how does each network know which device to forward which data to? Well, these are the questions that we want an answer to, and answer lies in the way that network is structured. There are several devices you may or may not have heard about, and these include routers, switches, and modems. These are crucial, for example, for your home network, for you to be able to access internet from your computer. Of course, it's the cables that are important, but what's the use of cables if we don't know who to forward the packets to? So, how does it all work? Well, let's start by talking about routers. Now, a router acts as the traffic director of a network. They are responsible for directing data packets between different networks, such as local area networks and wide area networks. This leads us to router's number 1 purpose, which is routing. Routers use routing tables and algorithms to determine the best path for data to travel from its source to its destination. They make decisions based on IP addresses, ensuring data reaches its intended target efficiently. It is also important to remember that routers work at layer 3 of the OSI model, which deals with IP addresses. Now, the OSI model is something that we will talk about later in the course, but for now just remember that router functions on layer 3. Now, typically routers today will perform the functionality of both a router and a switch. That means that the router will have multiple Ethernet ports that devices can plug into. Another use of routers is for network segmentation. Routers help segment networks, creating distinct broadcast domains. This segmentation enhances network security and reduces congestion. And also it is important to note that routers often perform NAT, or Network Address Translation, allowing multiple devices within a LAN to share a single public IP address. This conserves IPv4 address space and adds a layer of security. Now, I do understand that some of the terms that we talked about might be confusing for you, such as, for example, IPv4 or public and private IP or NAT, but don't worry about it for now. This is something that we will talk about shortly. For now, just focus on the main usage of these network devices. So let's repeat. Router is responsible for directing data packets between different networks by using routing tables to determine the best path for data to travel from its source to its destination. But what about switches? We mentioned that in some cases, routers can perform both functionality of a router and a switch. But what is the functionality of a switch? Well, switches, they use the MAC address of a device to send data only to the port the destination device is plugged into. Switches work at layer 2 of the OSI model, which deals with MAC addresses. Switches maintain MAC address tables to understand which devices are connected to which ports. This enables them to make forwarding decisions efficiently. That cable going out of your PC into the switch port is written inside the MAC address table inside the switch, so it knows exactly where your computer is and on which port should it forward the data to for it to arrive to your PC. Now, some of the pros or usages of switches are switches form the majority of network devices in modern data networks and carry huge amounts of traffic in telecommunications provider networks. Switches provide the wired connections to desktop computers, wireless access points, printers, industrial machinery, and some Internet of Things devices. They offer full duplex communication, connect network segments, boost network performance, and make effective use of available bandwidth. Now, network switches can be easily confused with routers. However, they have different functions and operate on separate layers. These differences include things like, for example, a network switch is a layer 2 device on the OSI model, and a router is primarily a layer 3 device. A router moves data between 2 or more computer networks, while a switch facilitates the sharing of resources by connecting multiple devices on a single LAN. To determine the route and destination of a packet, a router examines the IP addresses of packets, and a switch looks at the MAC address of each device to transfer data to the correct destination. Routers can work within both wired and Wi-Fi networks, but a switch is in most cases restricted to wired network connections. Okay, so these are some of the main differences, but we have to mention one more device, which is modem. What is a modem? Essentially, a modem is the device that physically connects your network to your ISP's infrastructure. It establishes the initial internet connection by translating digital data from your network into a format that can be transmitted over the ISP's network. Modems are essential because they are designed to work with different types of physical connections and communication standards or protocols. Each type of modem is tailored to a specific type of infrastructure or medium, allowing it to transmit and receive data over that medium effectively. Here are some examples. DSL modems are designed for transmitting data over standard copper telephone lines, typically using the digital subscriber line technology. Cable modems are meant for transferring data over coaxial cable lines, commonly used for cable television services. And for example, fiber optic modems work with fiber optic lines, which transmit data using light signals. Now, same as with switches, modems can also sometimes be confused with routers. So to summarize the differences that you should remember, we can say that modems and Routers are complementary devices in a network. Modems provide the link between your network and your ISP, enabling internet access, while routers manage local network traffic and provide additional features like Wi-Fi connectivity and security. In many home network setups, these functions are combined into a single device for convenience, known as a modem-router combo. Okay, client-server and peer-to-peer networks. What are the differences? Now, before I say what is what, let me first define what is client and what is server. Client is a device that is requesting a remote service or that is using a remote service from a server. And as you might have guessed, server is a device that is hosting that service to the client. A most simple example which all of you are familiar with are websites. Website is a server that is hosting a web page to you who wants to visit it. So your phone or laptop would be considered a client, while the website is considered a server. Now that we know this, it is rather simple to explain a client-server network. We can define it as the network that is organized around a central server that provides resources, services, or data. Clients, which can be individual computers or devices, request and use these resources. Servers are responsible for managing resources such as files, databases, web pages, or applications, and clients access and use these resources by requesting them from the server. It is often considered centralized since servers in client-server networks are typically more powerful and have more resources such as CPU, more memory, and larger storage compared to the client's devices. They handle requests and provide services to multiple clients simultaneously, and that is the reason why they also have to be more powerful. Now, on the other hand, peer-to-peer networks are opposite. Devices, or peers, in the network have equal status and can act as both client and server. Each device can request and provide resources to other devices in the network. It is also considered decentralized since peer-to-peer networks lack a central server. Instead, devices communicate directly with each other. They share resources such as files or processing power without relying on a central point of control. Each device in a peer-to-peer network is responsible for managing its own resources. Devices can share files, printers, or other resources without needing a dedicated server. It is normal to consider that in general peer-to-peer networks are less costly than client-server network. Alright, this would be the basic differences between these two, so make sure to remember them. Now that we got basics of networking out of the way, and that we discussed MAC addresses, types of networks, as well as network devices and their use, let us shift our focus on discussing different network topologies in the next lecture. See you there. Okay, just a quick pause. Here is an updated image of our simple network. And in the previous section, we talked about some of the most common devices inside of a network, such as switches, routers, and modems. We also mentioned that there are two main identifiers for each device inside of a network. We mentioned that those are MAC addresses and IP addresses. Now, while we did discuss about MAC addresses, IP addresses are something that we will talk about later in the course. Now, one more thing that we want to talk about in the course is how exactly these devices communicate. How do they transfer and share data? Well, those are the questions for the future lectures. For now, we are introduced to common network devices as well as MAC addresses. Now that we got that out of the way, let's go into the next section where we are going to talk about some of the most common network topologies out there. Alright, let us briefly describe different network topologies. We will start with one of the most common network setups, which is called star network or star topology. Now, in a star topology network, every node connects to a central network device, which in this configuration could be something like a hub, a switch, or a computer. The central network device acts as a server, and the peripheral devices act as clients. Now, each device on the network has a dedicated connection to the hub, which essentially creates a structure that resembles a star, and therefore it's called star network or star topology. Now, some of the key components of a star network would include central hub, and the central hub is typically once again a network switch, and it serves as the focal point of the network. It manages and controls the data traffic between connected devices. Another key component are nodes, which are individual devices or computers connected to the central hub. These can include things like computers, printers, servers, or any other networked device. Now, here are some of the advantages of a star topology network. Star topology network has centralized management of the network through the use of the central computer, hub, or a switch. It is also easy to add other computers to the network, and if one computer fails or stops working, the rest of the network continues to function normally. However, some of the disadvantages would be that it may have a higher cost of implementation, especially when using a switch or a router as the central network device. Now, the central network device determines the performance and number of nodes that the network can handle. If, however, the central hub or switch or computer fails, the entire network goes down and all computers are disconnected from that network. Alright, that would be some basic important stuff regarding star topology networks, and now let us discuss bus topology in the next lecture. Alright, bus topology network. A bus topology is a network configuration in which all devices are connected to a single central cable, which is called the bus. This cable acts as a communication pathway and data travels along it, passing through each device on the network. Now, each device on the network is equipped with something called network interface card that allows it to capture and process data packets that are relevant to it. Some of the advantages of bus topology would be that it is the easiest network topology for connecting peripherals or computers in a linear fashion. It works very efficiently when there is a small network. Now, the length of the cable that is required is less length than in a star topology. Another benefit of this topology is that it is easy to connect or remove devices in this network without affecting any other devices. It is also very cost effective as compared to other network topologies. The bus topology, however, has lots of disadvantages, and these would be that bus topology is not so great for larger networks. Also, identification of problems becomes very difficult if the whole network goes down. Same goes for troubleshooting individual devices, which also can be very hard to do so. Now, one important thing about bus topology is that it needs terminators which are required at the both ends of the main cable. And the reason why it is so good in a small network is because additional devices can slow the network down, so the larger the network, the worse the topology works. And also it's important to note that if the main cable was to get damaged, the whole network would fail. And last thing that we want to mention about bus topology are its key components, which include central cable or bus. And we already mentioned that the central cable is the backbone of the bus topology. It runs through the network, connecting all devices to a single communication line. And we also have terminators, which we mentioned. Terminators are located at the end of the central cable. They are used to prevent signal reflection and ensure that data does not bounce back and create interference. And last we have nodes, and nodes are simply devices connected to the central bus cable, which include devices like computers, printers, and other networked devices. A ring topology is a network configuration where devices' connections create a circular data path. each network device is connected to two others like points on a circle. Now together, devices in ring topology are called a ring network. And inside of a ring network, packets of data travel from one device to the next one until they reach their destination. Most ring topologies allow packets to travel only in one direction, which is called a unidirectional ring network. But others may permit data to move in either direction, which would be called bidirectional. Now, some of the advantages of ring topology would be that usually all data flows in one direction, reducing the chance of packet collisions. A network server is also not needed to control network connectivity between each workstation or device, and data can transfer between these workstations at very high speeds. It's also important to note that additional workstations can be added without impacting performance of the network. Some of the disadvantages, however, would be that all the data that is being transferred over the network must pass through each workstation on the network, which can make it slower than a star topology. The entire network will also be impacted if one workstation shuts down. And it's important to note that the hardware needed to connect each workstation to the network is quite expensive. Now, some key components of a ring network would be nodes, which are once again devices such as computers, servers, or network peripherals that are connected to the ring and that are responsible for sending, receiving, and processing data. And we have the ring, which is the circular communication pathway which is formed by connecting each node to its neighbor inside of a loop. And data packets travel around this ring. Now we also have something called multi-station access unit. In some implementations, a multi-station access unit is used to connect devices to the ring. It acts as a hub to facilitate communication between devices. Okay, we got two more to cover, which are mesh topology and hybrid topology. Mesh topology is a network configuration in which each device is directly connected to every other device, creating an extensive web of interconnected links. Now, there are two primary variations of mesh topology. We have full mesh and we have partial mesh. Now, in a full mesh topology, every device is connected to every other device on the network. This configuration results in a high degree of redundancy, but also requires a significant number of connections, especially as the network grows. In a partial mesh topology, devices are not connected to every other device, but they do maintain selective connections based on their specific requirements. This reduces the complexity of connections while retaining redundancy. Now, some advantages of mesh topology are high reliability, redundancy, scalability, fault tolerance, and security. While the disadvantages are complexity and cost, as well as bandwidth consumption, since in a full mesh topology, the numerous direct connections between devices can lead to increased bandwidth consumption. Now, key components of a mesh topology are nodes, which are devices like computers, servers, or network peripherals, which are interconnected with one another through direct links. And we have links, which are physical or logical connections between devices, such as wired or wireless connections. Alright, one last topology to cover, and that is hybrid topology. See you in the next lecture. Okay, hybrid topology. Can you guess what that is? Well, if you guess that it is a mix of already existing topologies, you were 100% right. A hybrid topology is a network configuration that combines two or more different network topologies into a single integrated network. This allows organizations to harness the advantages of various topologies while mitigating their respective drawbacks. Now, the choice of which topologies to combine depends on the specific needs and objectives of the network. Some key components of hybrid topology would include nodes, which are once again devices, computers, servers, printers, or network peripherals that are part of the network. And another key component would be the multiple topologies, which are actually the primary components of hybrid topology, and they are just various network topologies that are integrated for network to work. Now, common topologies combined in hybrid networks include star, bus, ring, and mesh. And some common combination types of hybrid topologies would include star-ring hybrid topology and star-bus hybrid topology. And let's also mention some of the advantages, which are that this type of topology combines the benefits of other types of topologies into one single network. This can of course be modified as per requirement, as it is extremely flexible and it is very reliable. Also important to note that it is easily scalable, as hybrid networks are built in a fashion which enables easy integration of new hardware components. Now, even though that hybrid topologies are mostly used in larger networks and they handle a large volume of traffic, error detecting and troubleshooting are rather easy to do. However, the two main disadvantages of hybrid topologies would be cost of implementation and complexity, since managing and maintaining a hybrid network can be complex, as it involves dealing with multiple topologies and ensuring their seamless integration. And logically, the cost of implementing a hybrid network can be higher than using just a single topology due to the combination of different components needed. Alright, that would be about it regarding network topologies, and in the next section we're going to talk about IP addresses, what different types of IP addresses are there, subnetting, and we're also going to show some networking commands that you can run from your PC at home. See you in the next lecture. Alright, IP addresses. We already know by now that each device connected to the internet has its own IP address. Now, remember when we talked about MAC addresses and how they are unique? Well, we can't really say the same for the IP addresses. This is because we can divide IP addresses into local or private and global or public IP address. Now, local or private IP addresses are something that you see inside of your network. They will only work within the network itself, and they are not used to route traffic outside your network. Typically, your router will have both private and public IP, where private IP will be for inside the network, while public IP will be used to route traffic through the internet. The private IP addresses are given to you by DHCP, which is Dynamic Host Configuration Protocol, and they are not unique since they are the same in lots of networks or in lots of local area networks. There are three main types or three main ranges of private IPs that we should be familiar with, and that is Class A, Class B, and Class C, and you can take a look at their ranges right here on the presentation. Now, you will most commonly encounter Class C in home networks, and this is the one with the range 192.168.something.something. You can check for yourself right now to see which range does your device belong to inside of your network. If you are on Windows, open your command prompt and type ipconfig, and if you are on Mac or Linux, open up your terminal and type ifconfig. Now, we should also be familiar with subnet masks. A subnet mask is a 32-bit value that is used to divide an IP address into two parts: the network address and the host address. It is used to determine which portion of the IP address represents the network and which portion represents the host. We have these three classes of subnet masks: Class A, Class B, and Class C, and you might notice that, same as IPs, subnet masks are split into 4 octets, and each octet has 8 bits. The left part of the subnet mask is for the network, while the right part is for the hosts. So for example, if we have 255.255.255, the left 24 bits are for the network, while the right 8 bits will be for the host itself, or for the hosts. Now, it's also important that we are aware of different types of IP addresses besides just private and public IPs. You might have also heard about IPv4 and IPv6 addresses. The ones that we just talked about are IPv4 addresses. An IPv6 address, on the other hand, are in hexadecimal format and they are 128-bit addresses. You can already figure that there are many more IPv6 addresses than there are IPv4 addresses, and that is exactly the reason as to why they were created. We were running out of IPv4 addresses, so we needed a different way of IP mapping devices. First 64 bits on the left side of the IPv6 address are for the network and other 64 bits are for the host. When it comes to IPv6 addresses, we have many different ranges of addresses, but here are the main ones that you should know. We have public IPv6 addresses, which can be used externally, and these public addresses will start with 2001, 2002, or 2003. Now, same way that IPv4 has local addresses, well, so does the IPv6. These local IPv6 addresses start with FE80. We also have unique local IPv6 addresses, and these start with FC00 or FD00. And also, since an IPv6 address can be quite long, there is a method of simplifying IPv6 address by removing zeros. So here we have an example of IPv6, and we also have an example of how simplifying it with removing zeros would look like. As you can notice, we used double column instead of all of these zeros, but it is important to note that this can only be done once. We can only use the double column once. So if you, for example, have multiple blocks of zeros in an IP, we can exchange the first block with double column, but the second block we must write as column 0 column and not just double column. Okay, that would be the basics of IP addresses. We talked about private and public IP address, and we also talked about IPv4 and IPv6 addresses. Now that we know that, in the next lecture, let's talk about protocol, which we mentioned earlier, and that is DHCP. Okay, let's quickly talk about subnetting and subnets. Now, this can be confusing for beginners sometimes, as it is considered a bit more advanced. However, we will still mention it and explain it as best as we can. So, what exactly is a subnet? A subnet can be defined as a logical subdivision of an IP network. Subnetting, on the other hand, is the process of dividing a network into two or more networks. There are many benefits of subnetting, such as, for example, security and improving network performance, but how exactly is it done? Well, we talked about subnet mask in the previous lecture, and remember that we mentioned terms such as network ID and host ID. And in the last lecture, we showed subnet mask that looks something like this. So 255.255.255.0. Well, there is another way that this subnet mask can be written, and it looks like this, /24. And before you ask any questions, I have a table ready that you can follow along to figure out the subnet mask notation. So the table looks like this. We have 3 rows, which are subnet, host, and subnet mask, and we have several columns depending on how many subnets are there. So if there is, for example, 2 subnets inside of a network, each of those subnets will have maximum of 128 hosts. And the notation for those 2 subnets would be /25. And if, for example, we had 16 subnets, there will be 16 hosts per subnet, and the subnet mask notation would be /28. So let's say that we, for example, have a network ID of 192.168.1.0/24. This would simply mean that this network has 256 hosts available. Now, typically your home network will have this type of subnet mask if subnetting has not been done yet. So, for example, if we look at the previous table, and let's say that we were given network ID of 192.168.1.0/24, and we are required to create 8 subnets from that ID. We would choose the fourth option in the table, which is 8 subnets, where each of those subnets would have 32 hosts, and those 8 subnets would have a subnet mask of /27. Let us look at that in a new table. So let us find out network ID, subnet mask, host ID range, and number of usable hosts, as well as broadcast ID of the example that we mentioned. So let's say the example again. We're given the network ID of 192.168.1.0/24, and we are required to create 8 subnets from that network, as well as fill in each subnet information inside of this empty table that we see. So first of all, we already said that each subnet mask will have /27, which we simply just read from the previous table. We can also read the amount of hosts, which would be 32 for each subnet. The network ID of the first subnet will be the same as our given network ID, which is 192.168.1.0. However, for the rest of the network IDs, we have to add additional 32 hosts each time. So for example, the second network ID will be 192.168.1.32. The third network ID will be 192.168.1.64, and so on, up to the 8th network ID, which will be 192.168.1.224. Okay, so we got the network IDs, and we got the subnet masks of all 8 subnets. Now, to calculate the broadcast ID, we can use the equation of the next network's ID last octet minus 1. So just to make it clear, the broadcast ID for each subnet would look like this. And we have the equation down below. You just take the next network's IDs. For example, if we are taking a look at the third subnet, which has the network ID of 192.168.1.64, its broadcast ID would be the next network's ID, which is the fourth one, which has the ID of 192.168.1.96 minus 1, and that results in third subnet's broadcast ID being 192.168.1.96 minus 1, which is 95. Alright, and we also need to fill in the host ID range, which is range between network ID and broadcast ID, which for the first network would be 192.168.1.1 up to 192.168.1.30. For the second one, it would be from 192.168.1.33 minus 192.168.1.62. And you can see for all the 8 subnets how the range would look like. So it is written in the table right now. Now, last thing that we want to fill in is the usable amount of hosts. So don't confuse the amount of hosts with usable amount of hosts. We know that each subnet has 32 hosts. We already saw that from the previous table. But if we remove the network ID and broadcast ID, we get that each subnet has 30 available hosts. The formula for calculating available hosts looks like this. So the total number of hosts in a subnet minus 2. And you can always read the total amounts of hosts in a subnet from the first table that we showed inside of the lecture. Okay, this one might have been tougher than last lectures, but make sure to rewatch it a couple of times if needed, and I'm sure that you will get it. Nonetheless, thank you for watching, and I will see you in the next lecture. Welcome back. Let us take a look at some of the basic networking commands that you can run on your Windows and Linux systems, as well as on Mac computers. So I'm just going to show on Linux and on Windows because Linux and Mac commands are rather the same. The only difference is between the Windows command prompt and the Linux terminal. So whichever system you have, whether you have Mac or Linux or Windows, you want to open terminal or command prompt. So if you're on Linux and Mac, open terminal, and if you're on Windows, just open command prompt. And the first command that we want to take a look at is the ping command. Most of you are probably already familiar with it. To ping a device, you simply just type ping and then the IP address or domain name. So for example, I want to ping google.com. I just type it in, and on Windows, it will automatically perform 4 ping requests. While on Linux, if I go here, ping google.com, it will ping as long as I let it run. So I need to stop this in order for it to stop pinging. You can see the difference. On Windows, it does it 4 times and then stops automatically. And here it will go forever until I Control C in order to stop it. And down here we have the command results, such as 16 packets transmitted, 16 received, there was 0% packet loss, and the time that it took for packets to arrive. So simply you can always use ping command to check network connectivity to a specified host or to a specified IP address. It works by sending ICMP echo request packets, and it measures the round trip time. Now the next command that I want to show you is called traceroute. Now traceroute shows the path that packets take to reach a destination. It displays the list of routers and different hops between your computer and the destination that you're trying to reach. So for example, if I type traceroute, once again google.com, it should give me the exact path of hops that it took to reach google.com. So let's leave it for a second to run. And here it is. It reaches the Google's IP, which is this one, in 11 hops. And this is the time that it took to reach it. And these are the routers or different hops that it took to reach this particular IP address. Now the same command on Windows is not spelled exactly the same. So instead of typing traceroute like we did on Linux and Mac, we want to type tracert and then the actual destination that we want to get the hops for. So let's do once again google.com, and let's see how many hops will it take from a Windows machine. And here it is. It shows 9 hops, which reaches the same IP address which we saw on Linux right here. So that would be the traceroute command. Now the next important command that I want you to know is the ifconfig command. So let me just clear the screen and type ifconfig, which is on Linux and Mac. It displays detailed information about your network interface, including IP address, subnet mask, and MAC or physical address. So here we have the local IP address of this Linux device, we have the subnet mask, we have the IPv6 address, we also know what IPv6 is, and we have the MAC address of this particular interface. Now, on Windows machine, the command is ipconfig. So it's not ifconfig, it's ipconfig. And it will give the exact same information. So down here we have the IP address as well as the IPv6 address and the subnet mask. The next important command, which you might find useful, is the ARP command. Now, we already mentioned before that ARP protocol is a fundamental networking protocol that is used to map an IP address to a corresponding physical MAC address on a local network. To check the ARP tables, you can type the command arp-a. This will display the ARP cache, which maps IP addresses to MAC addresses on your local network. So I typed it incorrectly, arp-a, and here is the ARP cache for this Windows machine. We can see the IP addresses and their respondent physical or MAC addresses. Now, same goes on Linux, except the command here is arp-n. So if I type arp-n, for now it only manages to find the gateway or the router IP address, which has this particular physical MAC address and this local IP address. Besides this, we also have the command called nslookup, and nslookup is a tool that you usually use to query a DNS server to look up information about a host name or an IP address. So for example, if you're wondering what is the IP of facebook.com, for example, you can use NSLOOKUP to get that result. So it will take a few seconds, and down here it will give us the IPv4 address of facebook.com. And you can do it vice versa. So for example, if you copy this and type NSLOOKUP and paste the IP address, so you don't get much information here except the name server, and that's about it. But you will find yourself using this command quite a lot whenever you want to figure out an IP address of a certain domain. This command is quite useful. Now, another command that you will use quite a lot if you end up in the networking or cybersecurity field is the netstat command. So if you type netstat nt, this specific command will print all the active connections that this Linux machine currently has. Now, since it doesn't have any active connections, there is nothing being displayed here, but if I was to open, for example, Firefox right here and run the command again, now we have a bunch of established and waiting connections. So you can even see what is the IP address and port being used on your local Linux machine, as well as the foreign or destination IP address that we are connecting to and the port that we are also connecting to on that IP address. So you can see that once I open Firefox, we got a bunch of results of port 443 and port 80, and you will learn in just a few lectures what these two ports are used for. Now, on Windows machine, you can also type nstat or netstat-nt, and it will print the exact same result. So here we can see the established connections and the ones that are in the close wait state. So whenever you are inspecting connections, make sure to also watch the state of the connections, because not all connections are active. Alright, and the last command that I want to show you is the route command. So if you type route-n, this will show you the routing table on your system. So in my particular case, it looks like this. It gives us the gateway, and gateway is simply just my router's IP address, which in this case is 192.168.1.1, but using the route command will show you the routing table. Alright, now these would be some of the simple networking commands which you can start using for whichever task that you might need them for. These are very useful, you will use them a lot in the networking field, and you will get used to all of these commands. And once you start using them, you will also discover some other networking tools and some other less common options that you can use with the tools that we showed in this lecture. Nonetheless, thank you for watching, and I will see you in the next lecture. Okay, so the OSI model stands for Open System Interconnection Model. This model is used to demonstrate or show how communication occurs between different devices on the network. It is considered to be a standard for how different computer systems communicate with each other. The OSI model consists of 7 layers. Each layer handles a specific job and communicates with the layers above and below itself. So let's discuss each layer a little bit. We have the physical layer. This layer includes physical equipment that is involved in the communication and data transfer. These are things such as cables and switches, for example, and this is the lowest layer since data here is divided into ones and zeros, or in other words, in binary. Next one that we have is the data link layer. Now, the data link layer is responsible for creating a reliable link between devices on a network. It deals with issues such as error detection and correction, as well as the organization of data into smaller packets. The data link layer takes packets from the layer above, which is network layer, and breaks them into smaller pieces called frames. The next layer that we have is network layer. And this layer is responsible for facilitating data transfers between two different networks. It deals with issues such as addressing and routing, and is responsible for finding the best path for data to travel. When we talk about packets, we typically refer to the network layer. Now, above the network layer, we have the transport layer. This layer is responsible for the end-to-end communication between two devices, and it also ensures the data is delivered reliably and in correct order. It deals with issues such as error checking and flow control, and it also breaks down data into smaller packets if necessary. Next, we have the session layer, and this layer is responsible for opening and closing and maintaining communication or connection between two devices. The time between when the communication is opened and closed is known as the session. This layer ensures that the session stays open long enough to transfer all the data being exchanged, and then closes the session in order to avoid wasting resources. The sixth layer that we have is the presentation layer. This layer is responsible for converting data into a format that can be understood by the above layer or the application layer. It deals with issues such as data compression and encryption. And the last layer is so-called application layer. This is the topmost layer of the OSI model, and it is responsible for providing a user interface to the network. It is the only layer that directly interacts with data from the user. You might have heard of application layer protocols such as, for example, HTTP or SMTP. Okay, now that we got this out of the way, let's go straight into network design and security. Alright, we discussed OSI model, and we are in the section where we will dive into some of the most known networking protocols, but before we do that, let us quickly define what exactly is a network protocol. Well, we can say like this. A network protocol is an established set of rules that determine how data is transmitted between different devices in the same network. It allows connected devices to communicate with each other regardless of any differences in their internal processes, structure, or design. Now, networking protocols are also a reason why you are communicating with anyone online, and for example, it's also a reason why you are able to watch this course. Now, there are many different protocols, and all of them are used for different things. Some key characteristics that protocols have would be rules for data formatting and data transmission, addressing, routing, error handling, and some even include security characteristics. Typically, security is found in newer protocols, as older ones weren't really focused on it before. Now, some of the most common protocols, and also the protocols that we will take a look at in the next few lectures, would be IP, which is considered the foundation of the internet and is responsible for addressing and routing data packets across network. We also have TCP and UDP, which are referred to connection-oriented and connectionless protocols. We also got HTTP, which is protocol used for transferring web pages and other resources over the World Wide Web. And we got other protocols such as FTP, SSH, DNS, which we will also discuss shortly. But nonetheless, this was just an introduction lecture where we defined what exactly is a network protocol, and now let's dive deeper into most known protocols out there. See you in the next lecture. Let us first talk about TCP/IP. Now, what is that? Well, TCP/IP stands for Transmission Control Protocol / Internet Protocol, and is a suite of communication protocols used to interconnect network devices on the internet. Now, TCP/IP specifies how data is exchanged over the internet by providing end-to-end communications that identify how it should be broken into packets, how it should be addressed, transmitted, routed, and received at the destination. TCP/IP requires little central management, and it is designed to make networks reliable with the ability to recover automatically from failure of any device on the network. Now, the two main protocols in the IP suite serve specific functions. TCP defines how applications can create channels of communication across a network, and TCP also handles message segmentation into smaller packets and their reassembly at the destination to ensure data integrity and proper ordering. IP, on the other hand, defines how to address and route each packet to make sure it reaches the right destination. Each gateway computer on the network checks this IP packet to determine where to forward the message. So overall, it is important to note that TCP and IP work together as a part of TCP/IP suite to enable communication over the internet. Now, while TCP manages the communication between applications and ensures data reliability, IP handles the addressing and routing of individual packets to ensure they reach the correct destination. But how does it work exactly? Well, TCP/IP uses the client-server model of communication in which a user or a client or a machine is provided a service, like for example sending a web page, by another computer or a server in the network. TCP/IP follows a layered architecture which helps organize and standardize the various networking protocols and functions required for communication on the internet. That layered architecture actually consists of 4 primary layers, which are application layer, which is the topmost layer. It is responsible for providing network services directly to user applications. It also includes protocols and services like HTTP, FTP, SMTP, POP3, and DNS, which enables applications to interact with the network. We got transport layer, and the transport layer is responsible for end-to-end communication and data flow control. And 2 of the most well-known transport layer protocols are TCP, or Transmission Control Protocol, which provides reliable, connection-oriented communication. It ensures, once again, data integrity, sequencing, and error recovery. It's used for applications that require data to be delivered accurately and in the correct order, such as, for example, web browsing and email. And we also got User Datagram Protocol, or UDP, which is a connectionless, lightweight protocol. It provides faster, best effort communication without the guarantee of reliability provided by TCP. Now, UDP is often used for real-time applications like video streaming and online gaming. Next up, we got the network layer, also called the internet layer, which deals with packets and connects independent networks to transport the packets across network boundaries. And last, we have the physical layer, also known as the network interface layer or data link layer, which consists of protocols that operate only on a link, which is the network component that interconnects nodes or hosts in the network. Now, a protocol in this lowest layer would, for example, be Ethernet for local area networks. Alright, those would be some basic stuff that you should know about TCP/IP structure. Always make sure to be familiar with the OSI model and the TCP/IP model. Now that we got this out of the way, let us talk about some specific protocols, starting with HTTP in the next lecture. HTTP is the foundation of data communication on the World Wide Web. It is a stateless application layer protocol that governs the transfer of data and resources such as web pages between a client, typically a web browser, and a web server. Now, HTTP stands for Hypertext Transfer Protocol. Most information that is sent over the internet, including website content and API calls, uses the HTTP protocol. There are 2 main kinds of HTTP messages. There are requests and responses. So let's define what are requests and what are responses. Now, HTTP requests are generated by a user's browser as the user interacts with web properties. For example, if a user clicks on a hyperlink, the browser will send a series of HTTP GET requests for the content that appears on that page. These HTTP requests all go to either an origin server or proxy caching server, and that server will generate an HTTP response. HTTP responses are simply just answers to HTTP requests. This response contains the requested content, which would be HTML code, images, or data, along with status information, headers, and other details. Now, one thing to note is that HTTP by default uses port 80. It is unencrypted, which means that it operates over plain text and that it is stateless, meaning each request-response pair is independent. The server does not retain any information about past requests from the same client. But if you're wondering how is traffic being unencrypted and in plain text secure, well, it isn't. It isn't secure at all. That is why we have HTTPS. Now, HTTPS is HTTP with encryption and verification. The only difference between these two is that HTTPS uses TLS or SSL to encrypt normal HTTP requests and responses and to digitally sign those requests and responses. As a result, HTTPS is far more secure than HTTP. A website that uses HTTP has HTTP in its URL, while a website that uses HTTPS has HTTPS in its URL. Now, HTTPS also uses port 443, which is another important thing to remember, and many of your social media websites or banking websites will be using HTTPS. At least they should be. If they are not, well, then there is a security issue. So these would be some of the basic things regarding HTTP and HTTPS. The most important thing to take away from this is that HTTP is unencrypted and HTTPS is encrypted as well as secure, while HTTP is not secure and it is data being transferred in plain text, which can easily be readable by an attacker. Also, HTTP uses port 80 and HTTPS uses port 443. Now, I encourage you to research more about these two protocols. They are important and you want to know more about them, so feel free to research about HTTP and HTTPS on your own. FTP, or File Transfer Protocol, is a standard network protocol used for the transfer of files from one host to another over a TCP-based network, such as the Internet. Now, FTP works by opening two connections that link the computers trying to communicate with one another. One connection is designated for the commands and replies that get sent between the two clients, and the other channel handles the transfer of data. Now, the protocol provides a way to list directories, upload files to the server, as well as download files from the server. It is widely used for tasks such as website maintenance, file distribution, and remote server administration. FTP interactions typically involve two key components. Client, and the client software is used to initiate connections to the FTP server, issue commands, and transfer files, and common FTP clients include FileZilla, WinSCP, and command line tools like FTP on Unix-like systems. And we also have the FTP server, which has the FTP software that runs on a remote machine and handles client connections, interprets commands, and manages file access. Now, popular FTP server software includes ProFTPD, VSFTPD, and FileZilla Server. Besides the key components, which are client and server, FTP also has two main modes. We have active mode. In active mode, the client initiates the connection for data transfer. The server connects back to the client to send or receive data. It's also important to know that active mode can encounter issues with firewalls and network address translation devices. The passive mode, however, is when the server initiates the data connection by listening on a specific port. The client connects to the server's port to send or receive data. And passive mode is more firewall friendly and is often the preferred choice for most modern FTP connections. Now, even though FTP is a widely known protocol and it exists for quite a long time, unfortunately FTP transmits data in plain text, which poses security risks. To address this concern, several secure FTP variants have been developed, such as FTPS, which stands for FTP Secure, and FTPS adds SSL and TLS encryption to FTP, which secures data transmission. It can operate in two modes, which are explicit and implicit. Now we also have SFTP, which is SSH File Transfer Protocol, and SFTP is a subsystem of SSH and provides secure file transfer over SSH connections. It is not, however, related to traditional FTP and FTPS. Now, despite its age, FTP remains a widely used protocol, especially in scenarios where simple file transfers are needed. However, security concerns have led to the adoption of these more secure protocols like SFTP and FTPS in situations where data privacy and protection are necessary. Now, in summary, FTP is a fundamental protocol for file transfer on computer networks, and its secure variants have evolved to address security concerns. All the users and administrators should choose the appropriate FTP variant based on their security requirements and network environment. Welcome back. DNS. Most of you have heard about DNS, right? It stands for Domain Name System, and it is a crucial component in your day-to-day website browsing. The most simple explanation of DNS is that it maps domain names to IP addresses. So, for example, without DNS, you would have to manually type IP address of each website that you visit instead of the actual domains. So instead of typing facebook.com in your browser, you would have to type 31.13.84.36, for example. Okay, you get the point. Now, DNS has several records, and we should be familiar with all of them. We have A records, which are IPv4 addresses or IPv4 hosts. We have the AAAA or Quad A records, which are IPv6 hosts. A CNAME or a canonical name is a type of DNS record that is used to create an alias for another domain or subdomain. We have MX records, and a DNS mail exchange MX record directs email to a mail server. A DNS SRV record specifies a port within a server for certain services. And we have SPF records, which are TXT files that DNS uses to stop the unwanted email traffic and to check if the email truly came from the domain from which it says it came. And we also have DMARC record, which is also a TXT file used by ISP to stop unwanted or phishing emails. Okay, so we know which DNS records exists, but how exactly does the whole process of finding an IP of a domain exactly work? Well, let's draw it here. As you can see, it is not a straightforward process. So let's go from the beginning. Let's say device A wants to search for a domain. First thing that's being checked are something called DNS cache. Now, DNS cache will typically store recently searched domains and their results. It does so for faster response next time that you search for that exact domain. If DNS cache is empty, it will check inside the hosts file. Now, hosts file is a file where you can write entries for certain domains, and this can be to either have quicker response time, or in case you do not want someone else to know about that entry, you can write it inside the host file because that file is stored on a host machine. In case both DNS cache and host files are empty, then the request is sent to the DNS server. When a DNS server is unable to resolve a hostname using its own cache and zone files, it will typically forward the request to other DNS servers that are higher in the hierarchy of the domain name system. This process is called recursion. If the result is found, it will typically get stored inside DNS cache for the next use, and if it's not found, the request will fail and you will not load the web page. Okay, so that is how searching for a domain and getting the web page back exactly works. But this is a security course, right? So let's also focus on DNS security. Let's start off by mentioning most common attack on DNS, and that is DNS poisoning. DNS poisoning is an attack where for certain domain, incorrect IP address is given, which can lead to a fake website. Now, poisoning can be done by injecting the record for that domain into any of the steps that we talked about on the previous slide. You can have DNS cache poisoning when the malicious record is injected in the DNS cache, which is first thing device checks once searching for a domain. So when that happens, even if you type the correct domain in the browser search bar, you will be led to the fake web page because that's what your DNS cache entry has. You could also poison the host file. However, in this case, if DNS cache has entry, then you won't even get to checking the host file, so you will still load the correct web page. If DNS cache does not have that entry, then the host file poisoning will work and you will once again go to the fake website. Now, besides DNS poisoning, DNS can be a target of several other attacks, which are DNS hijacking, DDoS attacks, or DNS amplification. Now that we know which attacks exist, we can conclude that DNS is not that secure on its own, right? Well, to increase our security, we can use DNSSEC. And DNSSEC strengthens authentication in DNS using digital signatures based on public key cryptography. Each DNS record is digitally signed, which creates something called RR signature record that can prevent certain attacks since it provides some type of integrity for the records and the results that you get. Now, DNS creates the RR signature record for each host. And another DNS security feature that you can have is something called DNS sinkhole. Now, DNS sinkhole can provide false information to the attacker, or it can forward the malicious requests to the honeypot, which will notify the IT team and keep the network safe. DNS sinkhole can also be used if you want to block certain types of content within the network, which can be done by leading the request for a certain domain to a non-existent IP address, resulting in request fail. So generally, DNS sinkhole is used to block both unwanted traffic and malicious traffic. Alright, that would be about it regarding DNS. Make sure to remember how DNS works, as well as what DNS records are and types of DNS attacks. And be familiar with the security solutions that we talked about when it comes to DNS. Now, in the next lecture, let's talk a little bit about IP addresses. Alright. SSH, which stands for Secure Shell, is a widely used network protocol that provides a secure way to access and manage remote servers and devices over an unsecured network. Now, it was developed in the 1990s as a replacement for less secure remote access protocols like Telnet. In the meantime, SSH has become an integral part of the modern computing landscape, offering strong encryption and authentication mechanisms to protect data and communication. Some of the key characteristics of SSH would include things like authentication, since SSH employs a robust authentication system to verify the identity of users and hosts. Typically, users are required to provide a username and password, or, for added security, an SSH key pair. Now, SSH keys consist of a public key, which is stored on the server, and private key, which is stored on the client. This asymmetric key-based authentication is considered highly secure and less vulnerable to brute force attacks. Now, secure communication is another good characteristic of SSH, since SSH establishes secure communication channels between the client and server. This allows for not only remote shell access, which is command line interface access, but also secure file transfers and tunneling for other network services like web browsing and database access. Port forwarding and tunneling are valuable features that enable the secure use of various applications over an SSH connection. And last characteristics that we want to talk about is portability. SSH is available for various operating systems, including Linux, macOS, Windows, and more. This cross-platform support makes it a versatile choice for administrators and developers working with different systems. Some of the use cases of SSH would be to have secure shell sessions, tunneling, secure file transfers, which is with SFTP and SCP, and remote server administration. Alright, those would be some of the basic things that you want to know about SSH. Alright, so we discussed most common networking protocols that you should know the basics for, such as HTTP, FTP, SSH, DNS, TCP and UDP, as well as we discussed about OSI model and TCP/IP model. Now in this lecture, we will just mention some other protocols out there which you might encounter or hear about, so we won't really be diving into the details about these protocols like we did with others. Okay, so besides the protocols that we already talked about, here are the ones that we should also remember. We have SMTP, which is Simple Mail Transfer Protocol, and SMTP is used for sending and receiving email messages between email servers. It handles the sending of outgoing emails from the sender's email client to the recipient's email server. We also have POP3, which is an email retrieval protocol that allows users to download their email from a mail server to their local devices. It is commonly used to retrieve emails and store them on the client side. And IMAP is another email protocol for retrieving and managing email messages. Now, unlike POP3, IMAP allows users to view and manage email messages on the server without downloading them, which makes it suitable for multi-device email access. Besides these protocols for emails, we have NTP, which is Network Time Protocol, and NTP is utilized to synchronize the time on computer systems within a network. Accurate time synchronization is crucial for various network functions and security measures. ICMP, or Internet Control Message Protocol, is responsible for error reporting and diagnostics in IP networks. It is commonly used with a tool that we already talked about, which is the ping command, which tests network connectivity. Alright, that would be enough about protocols, so now we know what exactly computers do over the network and how do they achieve things, whether that being loading a web page or connecting to a different computer or transferring files and downloading emails. It is all being done with different protocols. Now, there are a bunch of other protocols besides the ones that we talked about in this section, so feel free to research more about different protocols out there. Now that we got that out of the way, let us see a new update as to how the network functions. Okay, so here we are with our previous update to a network. We already have this simple network with computers, routers, switches, and a server, and we already know that each of these devices have their own IP and MAC address. But before, we didn't have the whole map. We didn't know how exactly these devices communicate or how do they exchange information. Now we know that they do so with the help of protocols. So each of these devices do their tasks with the help of protocols. For example, let's say that device A wants to load a web page which is hosted on the server. This will be done, as you already know, with the help of HTTP or HTTPS as well as DNS protocol if the web server is not in our network. But in this case, the web server is in our network, so we could access it with its local IP address and load the web page. We can also imagine that device B wants to, for example, enter and manage command line shell from device A. Now, how could it do that? Well, with the help of SSH, for example. So we get the full picture now. We know what common devices are inside of a normal network. We know how they are identified, which is with their IP and MAC addresses. And now we know how do they do their tasks, which is with the help of various different protocols. This is a basic understanding of how a network works. But that was the point of this mini course, right? To get the absolute beginners to understand how a network works in a simple way. But one thing is missing that we still haven't discussed, and that is network security. We now know how network works and how devices inside the network communicate, but we shouldn't leave the security aspect out, especially because I'm mainly a security instructor. So in the next section, let us briefly discuss about different types of network threats and protection mechanisms. Welcome back. Now that we got a full picture of how a network looks like and how it works, it is time we talk about another important aspect, which is network security. Now, before, network security was not considered, and that is why we have lots of old protocols which are now vulnerable to various different attacks. Remember when we talked about HTTP and HTTPS? Do you remember what was the difference between these two? Well, HTTP is unencrypted, or simply put, it is traffic being transferred in plain text. This is a security issue, as let's say for example you have a website that you want to log into with your account. If the website uses HTTP and you input your username and password, that traffic, including your username and password, will be transferred in plain text. This is vulnerable to the attack called man-in-the-middle attack, or MITM, which is one of the most common network attacks out there. It is when the attacker intercepts the connection between devices on the network so that all the traffic goes through the attacker's machine. Logically, if the traffic is going through the attacker's machine in plain text, well, then the attacker can simply read your username and password and gain access to your account on that website. The attacker performs this type of the attack by performing something called ARP spoofing. We mentioned before what ARP protocol is. ARP stands for Address Resolution Protocol, and it is used for IP to MAC address resolution. The attacker essentially sends ARP response to all the devices on the network, telling them that he is the router and sending them his own IP address. This response tricks other devices on the network to then forward their packets to the attacker, thinking that the attacker is the real router. The attacker, once receiving packets from other devices, then forwards those packets to the real router and establishes a man-in-the-middle connection like that. HTTPS prevents this, as it makes the traffic encrypted, therefore useless for the attacker, as the attacker cannot read them even if the connection is intercepted. Now, another common network attack that you most likely have heard about are DDoS, or distributed denial of service attacks. DDoS attacks floods a network or website with a massive volume of traffic, overwhelming the resources and causing it to become unavailable to legitimate users. Attackers often use botnets to launch these attacks, and what a botnet is simply a number of devices infected by the attacker, which are then used for various different attacks, including launching DDoS attacks. These devices are also called zombies. Now, DDoS attacks can also be used on various different services to make them unreachable or unusable, which is simply done by just flooding the traffic and making it slow to the point of it crashing. Another threat on a network, besides the two that we already mentioned, can be a malware or a worm. Now, malware is typically used to infect an endpoint device such as a laptop or PC, but these programs can also be designed to first infiltrate a network and then infect device on that specific network. Now, worms as well. Worms are self-replicating malware that can spread across network without user interaction. They can consume network resources and deliver payloads such as viruses or other malware. Now, these would be the most common threats on a network. Of course, there are others, but this isn't a security course. We just wanted to be introduced with most common attacks that can happen. In the next lecture, we will discuss the most basic methods that you can use to protect yourself against these type of the attacks. See you in the next lecture. Okay, let's talk about protection mechanisms against different network attacks. So there are two main types of security protection mechanisms that every machine should have, and that is antivirus software and firewall enabled. Now, in this lecture, we're going to take a look at simple firewall configuration in Windows, as well as Windows Defender and how it works. Okay, so to open the Windows firewall, we can navigate right here and type Windows Defender Firewall. We should have this option available right here, and if I click on it, it should open the firewall settings, and here they are. Let me just enlarge this a little bit so we can see everything better, and here are the firewall settings. So to enter the advanced settings, we want to click on this option right here, and this will require administrator password. I don't personally have administrator password enabled here, so it automatically opened this firewall settings, but for you, you might need to input the admin password first. Once you do that, this window will open up, and here we have the default Windows firewall. And we already mentioned before that firewalls can be used to set up filters or rules that are used to filter certain traffic. Here we can see that we have two types of rules, which are inbound and outbound rules. Now, inbound rules are for the incoming connections, while outbound rules are for the connections going from our machine. Now, by default, inbound connections are blocked on a regular Windows PC, while outbound connections are allowed. And we can see that by double-clicking on Windows Defender Firewall right here and clicking on the profile settings. So if I click Windows Defender Firewall Properties, it will open this small window where I will see three different profiles, which are domain profile, private profile, and public profile. Now, domain profile, it says right here, is behavior for when a computer is connected to its corporate domain. Private profile is behavior for when a computer is connected to a private network location, and public profile is behavior for when a computer is connected to a public network location. And here we can see the inbound and outbound settings for all three profiles. We can see by default, inbound connections are all blocked, and outbound or outgoing connections are all allowed. This is something that you can change if you wish, but these are the default settings. Now, if we go back right here, where we can once again see our inbound and outbound rules, this is the place where you want to set up your filters and rules. In a real world, administrators would customize the profiles using rules and filters so that they can work with user apps or other types of software. For example, an administrator or user may choose to add a rule to accommodate a program, to open a port or protocol, or allow a predefined type of traffic. Let's see how we can set our own rules. So if we click, for example, on inbound rules, we can click on this option that says new rule. It will open this window where we will have different types of settings or different types of steps that we have to go through for our rule to start working. So the first thing is, what type of rule would you want to create? Is it for a program? Is it for a port? Is it predefined or a custom rule? So let's say that we want to make a rule for a port. We want to set a rule that controls connections for a TCP or UDP port. We click on here, click on next. We choose whether the port is TCP. So for example, let's say the port is indeed TCP, and instead of setting all local ports, which will affect all the ports, want to specify a single port, and in this particular case, let's say it's port 7777. We click on next, and here we decide what we want to do with the rule. Do we want to allow the connection? Do we want to allow the connection if it's secure? And here we can customize this rule. Or do we want to block all the connections on this port? Let's say we want to block the connection. We click on next. We click on which profile does this apply, so you can apply it only on public profiles or on public networks, or you can apply it to all three, or just pick whichever one you want. So for this specific example, let's say that I want to apply this rule for all three domains. I click on next, and here I input the name. Let's say the name is test 123. Of course, you would not have named it like this in a real world, but just for the purposes of this example, I'll name it test123, and I'll click on finish. And here is my rule, test123, blocking the traffic, all profiles, it is enabled. And here it says, if we scroll, which type of action it is. It is block type of action. We want to block the traffic, any program, any local address, and any remote address. Alright, so that would be it about the basic rule configuration in the Windows firewall. You can play around with this a little bit and create new rules. But next thing that I want to show you, which is also inside the Windows system, is Windows Defender. Here it is, Windows Security. And both of these programs that we showed, including Windows Firewall and Windows Defender, are useful for protection against the threats that we mentioned in the last lecture. So worms and malwares, Windows Firewall and Windows Defender both are useful at protecting against both of them. Also, some types of exploits can also be stopped by Windows Defender, and you can filter different traffic with the Windows Firewall, as we already saw, so you can only filter the traffic that you want to see. Now, Windows Defender, on the other hand, is a lot simpler, so we just click on Virus and Threat Protection, and here you can scan your system for any malware or virus that is currently on your machine. You have different scan options down here, so we have Quick Scan, we have Full Scan, Custom Scan, and Microsoft Defender Antivirus Scan, and all their descriptions are down below. The Quick Scan lasts about 10 to 15 minutes, while Full Scan can be hours and hours long depending on the amount of files that you have on your system. You also have Account Protection, you have Firewall Network Protection, which we already talked about, you have App and Browser Protection. Here is also the Exploit Protection, which I mentioned a few seconds ago, Device Security, Device Performance and Health, and that would be pretty much about it. Also down here you have protection histories, so if you have previous Defender scans which found something, it should be displayed right here, and any potential security breaches or security concerns will be displayed right here. So it is rather simple to use. You just click on Virus Threat Protection and you scan the device for potential threats. Alright, so these two will help a lot to mitigate some of the threats that we talked about and some of the most common network attacks. So once again, thank you for watching, and I will see you in the next lecture, which is last lecture, where we put together the final image of our simple network. See you in the next lecture. And here it is, the complete picture of our basic network. We talked about everything from which types of devices are common to be found in the network, such as, for example, routers and switches. We also mentioned that to identify a device in a network, we use MAC addresses and local IP addresses. We also talked about different communication protocols, which could be, for example, running a web page and using HTTP and HTTPS to browse the content on that web page, or a protocol such as SSH, which can be used to open a secure shell on a different device and remote control it. And at the end, we mentioned some of the security mechanisms that these devices have, such as, for example, antiviruses for malware and worms, and firewalls for filtering certain type of traffic. Okay, awesome. If you have any questions which might be regarding this content that we covered or something else which you are interested in, feel free to ask so, and I will happily respond. Thank you for watching, and I will see you in some future course.